Science and Physics channel here. Today we'll be talking about the Tevatron. The Tevatron was a particle accelerator based in Fermilab. It's at Fermi National Accelerator Laboratory in Batavia, Illinois. I actually live right near there, actually, so it's kind of cool. So today we'll be talking about the Tevatron, and also, fun fact, the Tevatron did get deactivated in 2011, so that's not too good. I don't know if it is or not, but we'll figure it out soon. So anyway, I got some ambient music in the background for some reason. So let's talk about the Tevatron now. Let me set the camera. The Tevatron was a circular particle accelerator and active since 2011 in the United States at the Fermi National Accelerator Laboratory, also known as Fermilab, east of Batavia, Illinois, and holds a title for the second highest energy particle collider in the world, after the Large Hadron Collider (LHC) of the European Organization for Nuclear Research, CERN, near Geneva, Switzerland. The Tevatron was a synchrotron that accelerated protons and antiprotons in a 6.28 kilometers, 3.90 miles ring to energies up to 1 TeV, also known as electron volt, hence its name. The Tevatron was completed in 1983 and at a cost of $120 million, and significant upgrade investments were made in 1983 to 2011. Also, I'm very sorry if I'm sick. I'm kind of am, but I gotta record. Haven't recorded in so long, so I'm gonna start doing it today. So sorry if I sound a little sick. Try not to look bad. Okay, let's get on. The main achievement of the Tevatron was the discovery of in 1995 the top quark, the last fundamental fermion predicted by the Standard Model of Particle Physics. On July 2nd, 2012, scientists of the CDF and the DO experiment, Collider experiment teams at Fermilab announced the findings from the analysis of around 500 trillion collisions produced from the Tevatron Collider since 2001. They found that the existence of suspected Higgs boson was likely, with the only 1 in 550 chance that the signs were due to a statistical fluctuation. The findings were confirmed 2 days later as being correct, with a likelihood of error less than 1 in a million data by the LHC experiments. Tevatron ceased operations on September 30th, 2011 due to budget cuts. Hold on, I gotta set the camera again. It keeps being weird. And because of the completion of the LHC, which began operations in early 2010, and as a form of powerful planned energies were 27 TeV, also known as an electron volt. So 27 electrovolts beams at the LHC compared to 1 electrovolt at the Tevatron. The main ring of the Tevatron will probably be reused in future experiments, and its components may be transferred to other particle accelerators. The history. December 1st, 1968, started breaking ground for the linear accelerator LINAC. The construction of the main accelerator enclosure began on October 3rd, 1969, when the first shovel of earth was turned by Robert R. Wilson, NASA's director. This would become the 6.3 kilometers circumference at Fermilab's main ring. Excuse me. The LINAC first 200 MeV beam started on December 1st, 1970. The booster first GeV was produced on May 20th, 1971. On June 30th, 1971, a proton beam guided for the first time through the entire National Accelerator Laboratory accelerator system, including the main ring. The beam was accelerated to only 7 GeV. Back then, the booster accelerator took 200 MeV protons from the LINAC and boosted their energy to 8 billion electron volts. They were injected into the main accelerator. On the same year, before the completion of the main ring, Wilson testified at the Joint Committee on Atomic Energy on March 9, 1971, that it was feasible to achieve a higher energy by using superconducting magnets. He also suggested that it could be done by using the same tunnel as the main ring, and the new magnets would be installed in the same locations to be operated in the parallel to existing magnets to the main ring. That was the starting point of the Tevatron project. The Tevatron was in research and development phase between 1973 and 1979, while the acceleration at the main ring continued to be enhanced. A series of milestones saw acceleration rise to 20 GeV on January 22nd, 1972 to 53 GeV on February 4th, and to 100 GeV on February 11th. On March 1st, 1972, then NASA's accelerator system, accelerated for the first time a beam of protons to its design energy of 200 GeV. By the end of 1973, NASA's direct accelerator system operated routinely at 300 GeV. On May 14, 1976, Fermilab took its protons all the way to 500 GeV. This achievement provided the opportunity to introduce a new energy scale, the tera-electron volt, equal to 1,000 GeV. On 17th June that year, the European Superproton Synchrotron Accelerators (SPS) had achieved an initial circulating proton beam with accelerating radio frequency power of only 400 GeV. The conventional magnet of main ring was shut down in 1981 for installation of superconducting magnets underneath it. The main ring continued to serve as an injector for the Tevatron until the main injector was completed west of the main ring in 2000. The energy doubler, as it was known then, produced its first accelerated beam, 512 GeV, on July 3, 1983. Its initial energy of 800 GeV was achieved on February 16, 1984. On October 21, 1986, the acceleration at the Tevatron was pushed to 900 GeV, providing a first proton-antiproton collision at 1.8 TeV on November 30, 1986. The main injector, which replaced the main ring, was the most substantial addition, built over 6 years from 1993 at a cost of $290 million. Tevatron Collider Run 2 began on March 1st, 2001, after successful completion of that facility upgrade. From then, the beam had been capable of delivering an energy of 900 GeV. On July 16, 2004, the Tevatron achieved a new peak lumosity breaking record previously held by the old European Intersecting Storage Rings (ISR) at CERN. That very Fermi Lab record was doubled on September 9, 2006, then a bit more than tripled on March 17, 2008, and ultimately multiplied a factor of 4 over the previous 2004 record on April 16, 2010, up to 4 times 10, 32 centimeters, negative 2s, negative 1. I really don't do those math problems. I'm kind of sorry. I don't know how to do that. I can't really say I'm right either. So it's kind of not too good. The Tevatron ceased operations on September 30th, 2011. By the end of 2011, the Large Hadron Collider LHC at CERN had achieved lumosity almost 10 times higher than Tevatron's at 3.65 times 10 to the 33 centimeters, negative 2s, negative 1, and a beam energy of 3.5 TeV electrotron each, doing so since March 18, 2010, already 3.6 times the capabilities of the Tevatron at 0.9 TeV. That is going to be it for this video. This is a Physics and Science channel. If you want to ask any questions, please head to the discussion, or please head to one of the YouTube videos and comment. Thank you for watching, and this has been the Physics and Science channel. Part 2 coming out tomorrow.